Good morning, everyone. I'm Liu Zhifeng from Jollywood. I'm honored to give this presentation, the development of 24% efficiency N-type TOPConsolar cells and modules. The presentation consists of the following four parts. Firstly, I will give an introduction, mainly introduce Jollywood tidal solar technology and its technology roadmap. The second part focuses on the progress of N-type TOPConsolar cells and modules obtained by Jollywood. Thirdly, I will report the applications of N-type technology. The last, I will give a conclusion. Jollywood tidal solar technology, it was founded in 2016. Registered capital is $330 million. Jollywood focuses on the production of N-type solar cells and modules. We have TOPConsolar cell capacity 2.1 GW, IBC solar cell capacity 150 MW, and N-type module capacity 3 GW. Now, Jollywood is a Tier 1 brand of Bloomberg. Why Jollywood chose N-type technology? We all know that high efficiency and lowest LCOE are targeted in PV industry. We believe N-type technology can meet the two requirements at the same time due to N-type technology has three high and two low: high efficiency, high beneficiality, and high reliability, low degradation, and low temperature efficient. The forecast from ITRPV showed that N-type marketing will grow fastly with a new rate of 34% in the next few years. Based on those reasons, Jollywood has established its N-type technology roadmap. There are three generations N-type technology. The first generation is N-port technology. We had been produced N-port solar cell from 2016 to 2018, and the average efficiency was 22% with capacity 2.1 GW. Now, we have upgraded all N-type lines into N-TOPCon lines. The efficiency increases from 22% to 23.5%. The other second generation technology is N-type IBC technology with efficiency of 23.5%. The third generation technology is N-type TBC technology. It combines the benefits of N-type TOPCon and N-type IBC. On the front side, there is no electrode heating. On the rear side, it uses N+ and P+ poly to pass with the rear side. So, for the TBC solar cells, it will have higher short current and higher open voltage. Its efficiency potential should be exceeding 25%. Jollywood attaches great importance on patent application. Now, we have applied 134 patents. 67 patents have been granted, and 21 of those granted patents focus on the N-type TOPCon technology. This is the cell structure of Jollywood TOPConsolar cells. The front side consists of the P+ emitter, aluminum oxide, and silicon nitride coating, and then printing silver fingers. In the rear side consists of tungsten oxide and N+ poly, then deposit silicon nitride and printing silver fingers. The N+ poly was formed by LPCVD, intrigued poly, and then used ion implantation to doping phosphor. Due to the passivation quality of N+ poly is very good and can pass with the metal contact. So, for TOPConsolar cells, the VOC is usually exceed 700 mV, and the temperature efficiency will be extremely low. It's about -0.32% per degree. For the TOPConsolar cells, it uses N-type materials. It have high bulk lifetime and no LID. So, TOPConsolar cells have very low degradation. The first year degradation is -1%, and the annual degradation is -0.4%. TOPConsolar cells have double-sided silver fingers. The width of finger is just 30 micrometer. The finger widths of front side and rear side are almost the same, so it have a high bifaciality of 85%. This is the newest result in R&D lab. The average efficiency was up to 24.1% with an excellent open voltage 704.7 mV are obtained in R&D lab. Jollywood office focus on the efficiency improvement. In the next few years, we will improve the efficiency by using silicon emitter in the front side and optimize IRC coding, double-sided electrode, and using thin poly layer, and so on to improve the efficiency from 24% to 25.5%. This is the result of TOPConsolar cells in mass production line. The average efficiency is 23.85, and the average open voltage have exceeded 700 mV. Those are N-type TOPCon modules products. We have the following 4 products. All the module efficiency have exceeded 20.5%. The highest module efficiency exceeds 21% for N-type TOPCon 9-busbar 156 half-cut cell module. We also announced that for black modules, the module power is 345 watts and efficiency is 20.5% for 120 half-cut cell module. In the table, the cell size was G1 wafer. This is a summary of benefits of N-TOPCon bifacial modules. It have high bifaciality of 80% to 85%, high reliability, low degradation, low temperature coefficient, and better low illumination response. All those benefits will bring at least 5% power gain than P-type bifacial modules and 12% power gain than POC monofacial modules. This is the module power roadmap for the G1 cells. We improve the module power 20 watt per year for the same size module. In 2021, we will achieve a module power of 470 watt for G1 size 156 half-cut cell module. If using 182 millimeter wafers, the module power will be 560 watts for 144 half-cut cell modules. It was well known that for the N-type solar cells, there is lower LID and LETID. For the LID, it because of no boron-oxygen defects that leads to no degradation for N-type materials. For the LETID, the research shows that N-type cells and modules are significantly less than P-type materials. It is because that the high precursor in the N-type materials is much less than P-type, which have been confirmed in academic cycles. This was a test result about LETID from Fraunhofer CSP. The data showed that the LETID was exceeded 2% for P-type multi-silicon modules and 6% for P-type mono-silicon modules. Those degradations were induced by temperature and light soaking. This is another result from TOV node about the LETID test. We find that the LETID degradation for the POC modules is about 2 or 3%. For TOPCon modules, we can find that after LETID test, the power of N-type TOPCon modules increased by 1%. This is the result from Jollywood R&D lab. We can find after LETID test, the module power have a gain about 0.6%. So, for the N-type TOPCon modules, the LETID will lead the module power have some gain, not a degradation. We have many international cooperation with such as IMEC, ECN, Sharp, and some local university. And those cooperation will keep Jollywood, keep the technology tier 1 in the N-type technology. Now, I will introduce some applications of N-type modules in power plant. The first one is the Panta project. Jollywood offered 29 megawatt bifacial modules in this project. The data shows that the power gain of N-type bifacial modules is about 30% than P-type monofacial modules. And this is the top runner project, Sihong Fishing Farming project. Now, it is the world's largest N-type solar farm. The total capacity is 1 gigawatt. And this is the largest N-type bifacial project in European. The data show it have 8 to 12% power gain compared with the P-type monofacial modules in the same region. This is a Middle East project. The project capacity is 125 megawatt, and it's the largest N-type bifacial modules in the Middle East. And this is the largest N-type bifacial project in Europe with vertical installation. The high bifaciality of N-type modules enable the solar plant to gain more energy yield. Now I will give a conclusion. Jollywood has 2.1 gigawatt TOPConsolar cell capacity and 3 gigawatt TOPCon module capacity. And we also have 150 megawatt IPC solar cell capacity. Now we can achieve the average efficiency of 23.8% in our mass production line and 24.2% in our R&D lab. Jollywood developed a full black modules with module power 345 watt and efficiency 20.5%. The module weight is just 19 kilogram. N-type TOPCon bifacial modules showed no or negative LID or LETID degradation due to the excellent N-type materials. Jollywood bifacial modules have been widely applied in large amount of PV systems in the world. In the solar farm, it always bring more than 10% power gain from the bifacial design than monofacial modules. Okay, thank you.